Okay, announcement number 1. We're working on getting more handouts. I printed them out, but there was a big job in front of me, and so I didn't get them in time. But we have a request in. I suggest that you share. We are actually going to do some work on them, but it'll be better work if you can talk to somebody about it anyway. So it'll be okay. The second thing I want to do today is introduce you to a friend of mine who I had not seen in over 2 years at 11 o'clock this morning when he popped in. And he's a former CS225 course staff. He wanted to come by and say hi. Oh, except that I'm attached here. Here you go, Veer. This is Veer.
Hey, guys.
Aren't they friendly?
Yeah, your classes are very friendly this year. We're definitely not this friendly. So yeah, I'm visiting for the day. I took this class, I loved it, did really well, and was like, hey, I'm going to be a TA. And I did that for like 2-ish years, probably. So if you guys do well, contact Cinda and be like, hey, I want to be a TA, because TAs are amazing. The other thing, so I graduated in 2014. Since then, I went to work near Boston at MIT Lincoln Laboratory, National Laboratory for Cybersecurity. Or I was doing cybersecurity at the National Laboratory, working on like defensive prototypes and research. You can ask me about that offline. And then 6 months ago, I changed over. I'm working at Google now. And so if you're interested in that, you can also come talk to me after class. I'll be here. And yeah.
Yay.
Anything else?
Yeah. It's really great to see you.
Keep talking until the handouts come.
No, they'll be okay. They'll survive. The first few slides are actually on your handouts from last time. You know that, right? Like that there's all this overlap every time, because I'm eternally optimistic. And my biggest fear is that I'm going to run out of stuff. So this is all playing defense. Okay, so thanks, Fear. Oh, yay. Okay. Yay, Wade. Wade saves us all the time. Okay, so I wanted to bring up, I have a question for you, because I do not know the answer to this. Has anybody done today's problem of the day? Because it doesn't exist, right? I think that one just slipped through the cracks. It's Monday morning in all kinds of ways, except that it's not. It's Monday afternoon now. It's Monday in lots of different ways. So I don't know how we'll handle it. We may release 2. We may just skip it. But this is all extra credit anyway. So I'm not going to feel too guilty about it. I will, however, talk a bit about exam. Oh, I can't talk too much. So there's a question about exam 3, and I'm not going to answer anything specifically about exam 3, but let's see if this solves the issue. So we don't overall yet know what the distributions over these exams look like in total. And what we fully expect is that on any given exam, there's going to be a lot of variability among you, and that, you know, there are going to be exams that you just feel like do not reflect your skill at the class. Now, if in the end, I mean, there are lots of different ways we can measure this, right? Like if in the end it looks like, gosh, you know, there would be a lot less variability if we let everybody drop their lowest exam, then we'll consider that as a policy. But I don't want to make any promises about, like how we'll adjust the grading policy mid-semester. I want to look at numbers and, you know, see what it looks like for everybody. And I think I feel safe in saying that in the end, whatever we do will be fair and have impact pretty much evenly across you. And it certainly won't explicitly hurt you from the originally stated grading scheme. So if you are unhappy with how you've been doing on the programming exams so far, I guess I'm asking that you trust us a little bit. We're also happy to talk to you about strategies for strategies for improving. So, all right. Any other administrative questions? Yeah, Neil? The question is, should we consider doing something similar for the quizzes? And the answer is yes, you get to drop 4 quizzes. So we already are for the quizzes, and it's an issue of the CBTF stuff that's different, the programming exams that we're talking about. Okay, anything else? Any other administrative issues that we should be worried about? Oh, yes. So I put Lecture Helper, the link again here. And actually, I think you should have put that in as a Lecture Helper thing. Like you should communicate with me via the I'm just kidding. Yeah. Yeah. Okay, so I want to tell you something about Lecture Helper here. We're actually going to be collecting data this week. And that means we would like you to view it as a tool. What we've observed so far is that you and I both forget that it's available. So there are all kinds of questions right at the start of the hour, and then not so many toward the end. So I may pause. Oh, no. I may pause and remind you that it exists, or, okay, it's all okay. But you try too. If you feel like you want to communicate with me and I'm missing some key points, I can see questions right here. And I'm trying to remember to look. Okay, so last time we were in the process of revisiting C++ for this very specific purpose of investigating a very general form of writing code. And in fact, we call it generic programming. Now, I have replicated most of the code that we scrutinized last time because I want to remind you about a very specific part of it. The part that I want to remind you about, you'll need the animal class for later, but nothing there is surprising. The part I want to remind you about is this for loop. And to note that we've got a new kind of thing going on here. Okay, we've got a new kind of thing. Now, the key observation for that new kind of thing that we happen to refer to as an iterator is that it can both be incremented and I'm going to put this one in quotes because it's sort of misleading, dereferenced. And the reason I put this in quotes is because it doesn't necessarily have to do with memory. It's not necessarily a memory operation. So what this code does then is it sets up this tool for looking at our data, both the name and the food of anything it refers to, and it does so sequentially over the, in this case, list. Okay? So the iterator is this abstract way of looking at what's inside our object, even if we have no idea how that object is implemented. All right, any questions so far? All right, so I have a little picture that I think clarifies this a little bit. The idea is that we've got some class that for now holds some kind of sequential data. And we first refer to that class as a container. Now, the most important part is that we don't know how memory is configured inside. We have no idea what those boxes mean. We don't have a model for what's going on in memory, but the client code may need to both access the data inside the container and similarly iterate over the container. That is, it will want to look at where it is now. This iterator will want to look at the data where it is now, but then also have an idea of where's the next one. Okay? It needs to be able to look at where it is now and then know where's the next one. Now, in some cases, so this part, the look at what it is now, is like the dereference thing, but the process of moving to the next one is the increment. Now, some iterators provide not only a next one, but also a previous one. Can you imagine how they might do it? Yeah, they will implement the minus minus operator, so you could go backwards. Some will do both. Some will be backward iterators. Some will be only forward iterators. And most container classes provided by the standard template library will have constant versions of all of those, so that an object here, or a client iterator, can look at the data inside the container but cannot change it. Okay? I have a link on the next page that tells you, that gives you a reference for iterators in the standard template library. Okay? Now, the question is, we still don't, the question on the floor is, well, what are these things? We still only kind of refer to them abstractly. We don't have a notion of what they are. They're, yeah, I sent them to the printer. There should be a print job. Oh, okay. A big job. Oh, okay. Okay. They'll be there eventually, maybe? Okay. Thank you. Raise your hand if you don't have a handout. Oh, man. Heck. I'm sorry. Raise your hand if nobody sitting beside you has a handout. Oh, I'm sorry. Okay. Especially the very back people, because they can't even see the screen, right? Like, you guys might as well, like, I don't know. It doesn't help for me to walk back here. I can't, like, show you. Here, look. Is this better? It's almost better, right? Okay, let's keep going. So we have it's okay to take a little break here, because what I'm admitting to you is that we've got this abstract notion of an iterator, and we do not know anything about its implementation. So that's what we're going to spend the next few minutes talking about. So, and let's see. I don't actually tell you this because I think you're going to be implementing them. I tell you this because I want you to understand what's going on, and I want you to be able to use them effectively, like, for example, in MP4 even. So, let's keep going. So the rest of this here and the next slide is all about implementing iterators. Okay, so we said that we have this container and we've got this configuration of memory inside, and I want to speculate on what the implication of the configuration in memory would be if we were to define an iterator on it. So let's pretend for just a second that we're wrapping up a linked list here. So we've got linked memory. We know we have a list node in the private section of the class so that we can define this thing. And we've got this head pointer. Now my question is, if you wanted to keep track of where you were in that memory, what kind of thing, what type of thing would you use to do it? You want to keep track of where you are. What kind of thing would you use to do it? Yeah? Yeah, what kind of pointer? A pointer, what kind? Let's call it a node pointer. That's right. Not list node. I don't have room to write out list node. Okay? So we've got this node pointer, and I want to use it to keep track of where I am currently. And what that means is that the private member associated with the iterator class that we're defining is a node pointer in this context. If that's true, how do I increment it? Yeah, good. So the plus plus operator in the iterator class would simply go cur equal cur next. Good. And I know there are probably some edge cases, like, you know, if we're not at the end, or if we are at the end, there should be a sentinel. There might be some details here that are missing, but you can figure out those details. They might be a debug cycle. Okay, then finally, what does a dereference look like? That is, how do you look at the data inside of it, the data associated with the iterator itself? Yeah? Yeah, good. It's cur's data. Very good. All right, and we'll talk on the next slide of what we do with all this stuff, okay? All right, now let's alternatively look at what happens if we put a class around an array. We're going to put a class around array. So I'm going to pretend that we've got this thing called R, which is the array, okay? Just as we had head here, we've got an array called R here. R. Now, if you're trying to keep track of where you are in that array, what would you use to do so? Say it louder. An index. What kind of thing is an index? Probably an int, and I'm just going to call it K because K is easier to spell than index. All right? How do I get to the next one? How do I increment my iterator? What's the beef of the overloaded plus plus? Yeah, K++, the easiest thing you're going to do all day. Okay, good. And then how do you look at the data inside? That is when we, quote, dereference the iterator, what are we actually going to give back? What are we going to return from that function? Any ideas? What letter am I going to write? A, good. R, K, arc. Okay, any question about it? All right, so these things are going to inform the way the iterator class looks and what it contains, okay? All right, fine. These are two very simple examples that we actually could do. You won't have to. We only need you to use them. You will not have to define them explicitly, but you could. In fact, you can put a class around any kind of container object, a container object configured any way you want, and as long as you can define those three things, you've got an iterator. So for example, in a hypercube, we don't really know yet a really smart way of iterating over the hypercube. There are lots of different choices that we could make. There were choices before too, but we didn't go there, okay? There are lots of different choices we could make. We could start here and go like this and then go down and do the bottom. Or we could do a node and each of its neighbors and then each of their neighbors. There are a couple different perfectly reasonable ways of navigating all of the data in this thing that's configured like this. In order to talk about the details of these three things, though, we would need to know what the heck that looks like, right? They're intimately connected. So we're not going to do this here, but I want you to kind of understand the questions that you would have to ask in order to solve that problem. All right, so any questions? You good? Okay. There is? Oh, sorry, Mark. A hypercube is a particular kind of graph, and there are some very, very clever ways, actually, of iterating over this graph. Okay. Any other questions? Okay. So I have a little challenge for you, and I think you have all the tools to figure this out. So I'm not going to ask you to do this in any other context besides here, but I think I could because you're bright. So here's an apartment building class. It encapsulates some kind of container. It has a whole bunch of data in it. Now, what that data looks like in memory, I'm not going to tell you. I don't even know, okay? We're not going to look at it at that level of detail. Maybe it's like a, what is an apartment building? It's like a 3D array, right, of boxes that are, I don't know. Maybe it's 2D. I don't know. Anyway, let's see. So I don't know what the memory looks like, but I can still figure out where all of these elements go. So what I want you to do is spend a couple minutes kind of drawing arrows between the iterator class, those begin and end functions, the overloaded operators, and the representation of the iterator. That is, how do we keep track of its state? I want to know where those go, and before you start working on it, I want to give you a big hint. You already saw begin and end used here. So I assert that that's all you need to know to answer the third one of those. Okay? So spend a couple minutes kind of sketching out what this iterator looks like inside this class. Does anybody have any extra handouts that they were willing to share? You ready to chat? No? Let's chat. All right. We can tell from this right here that the iterator is a class inside the container class. My question is it public or private? Raise your hand if you think it's public inside the apartment building class. Raise your hand if you think it's private inside. Okay, so I know what you're thinking if you think it's private, because every time we defined a class before, we put it in private, right? Like list nodes, for example. But this time, this is a class that we're providing for use in the client. So this one is public. So here we have, inside, we have class iterator and some stuff inside the public portion of the apartment building class, okay? Now, I'm going to break this down into 3 regions. And the next thing I want to know is where do those member functions, where are they defined? And I want you to raise your hand with what you think. 1 or 2 or 3. Regions 1 or 2 or 3. Raise them high. Can't see. Or 4 or 10. 1 or 2 or 3. Okay? I'm going to help you answer your own question. Which kind of object are they called on? What kind of object are they called on? Zoo was a list, right? Here it would be called on an apartment building. Apartment building dot begin. This would be like the supervisor's house or something, you know? Right? It would be the beginning of the class. All right, and moreover, the client can use them. So the answer is 2. So begin and end go here. What kind of thing do they return? That is, what's their return type? An iterator. That's right, they return an iterator. Do we know what an iterator is? Why, yes, we do. We just defined it. Who knew? What do you think begin returns if my apartment building is implemented as a... No, that doesn't make sense. It just returns the beginning. Okay, never mind. Okay, where do these guys live? Again with the 1, 2, or 3. Again with the 1, 2, or 3. Overloaded operators, 1 or 2 or 3. 1 or 2 or 3. Who calls them? They're overloaded operators of a iterator. So they're in the iterator class. They're 1. But now what I want to know is, are they public or private? That is A or B. And here's how you do it. This is sign language for A, and this is sign language for B. Okay? So like this or like this. Like this or like this. Public or private. And the way to answer it is who gets to use it. The answer is this. Okay? They're public. Public, public, public. You are making them for the client to use. Okay, so these are operator plus plus, and they return an iterator as well. Okay. Actually, they just void, I believe. They just increment the private member. Okay, then finally, I want to know where the iterator representation lives. That is, that private member that we defined in the first column in the previous page's table, where does that guy live? Where do we keep track of the current status of our navigation of that thing? How do we keep track of where we are now? First with a number, well, I guess that gives it away, right? First with a number. The only one that has options is 1, right? So the iterator is going to keep its own state, and I'll talk about that for just a second. And is it public or private? No yawning. Wake up. Yeah, that one's public. I'm sorry, private. I should wake up. All right, that one's private. And the reason is because you don't want your client changing the state of the iterator without your control, right? You want them to change the state of the iterator through the plus plus. All right, so let's see. So under private goes the representation. Now, you may ask, why not put the iterator representation here? Why not have an iterator associated with the, say, apartment building class? And the reason for that is if I say apartment building A and B. So I'm going to define two apartment buildings. I'm sorry. I'm going to define an apartment building. I'm sorry, I'm distracted. I'm going to define an apartment building, and I'm going to define two iterators on it. Okay, so it's going to be apartment building, iterator, IT1 and IT2. You can have one iterator that goes slowly and another iterator that goes quickly through the class, right? And if you store zoo.begin, ita.begin, a.begin. Yeah, okay. If you store the state inside the apartment building class, then both of these things will refer to the same space. You can't move them separately. So each one of these iterators needs its own state, and the place to store that is inside the iterator class. Okay? Objects of that type can store their own state. All right, you okay with this? Yeah, you're kind of relieved that I'm not going to ask you to do it, right? Yeah. So here's the thing, though. You could, if you had to, you could do this. You can certainly diagnose what's going on by looking at code, sort of like you saw on the blue part. Now, what I think is more interesting and a little bit harder is the application of these things. So let's move on to a little bit more magic here and talk about kind of a clever way of using these iterators. Yeah? Oh, these are not, so the question is about begin and end. And I'll remind you that these are not data, these are functions. These are functions that you call on the apartment building class. So here, I'll fill out my example here. I'll make it in green so you can tell where I'm writing, okay? I'm working on my example. So I can say now, iterator 1 equals a dot begin. Okay? And now iterator 1 starts at the start of the apartment building. I can say iterator 2 equals a dot end. And now we've got another iterator at the end. You can imagine a person standing down there at the other end of the apartment building. If that iterator starts walking this way and I start walking this way, you can make the iterators meet each other in the middle. Okay? And they're both iterating over the same thing. The thing that unifies them is this begin and end function. Okay, does it feel okay? All right, they each have their own state inside. Okay, how are we doing? It's all right? So let's do a little trick here and see if it makes it better. This first slide is a bit of an aside. It's a little bit different. I'm going to pull it all together later. Okay, so take a look at this code and remember what we did before. And the first thing I want you to do is declare an object of type animal. Here, I'll even do it for you. Uh-oh. Maybe not. Wait, it's not even writing on my own screen. Can I just replace the battery? How do I declare an animal A? Somebody volunteer. Animal A, right? If anybody lost a wallet in here, I have one. I've probably had it since Friday. Sorry. Could today get any weirder? I don't know how it would have changed. Uh-oh. Okay. I know. Let's get rid of, let's make sure that we don't bring our slides, and then also make sure that the presentation doesn't work correctly. How about that? Okay, we're good. Okay, declare an object of type animal. Animal A. Pretend it's an ant or something. We can instantiate it however we like. Though the no argument constructor from that would be a big blob that eats you. Okay, from last time, that's review of last time. Now, I have a new class defined, and I want you to declare one of those. How do I do it? I've got a new class. I want to declare one of those. Yeah? No? Okay. You do know, though, because it's just print if big P, right? It's just a class. This is how I declare one. Now the question is, how do I invoke that one member function of the printf-big class? How do I invoke it? Think about that for just a second and raise your hand with the hand or hands with the number of characters you would have to use to invoke that single member function of the printf-big class. Raise your hand with the number, and you don't have to print out the semicolon if you don't want to. Very good. Good. So this is P of A. I'll put the semicolon there. And I'll point out this is exactly the same as P dot operator parentheses with A as an argument. Okay? It's exactly the same. This is how you use it. All right? Any questions about that? Is that okay? Yeah? Yep. If you have more than one member function of printf-big, this will still be the case. You can still do this. In fact, in MP4, you're going to have data associated with these generic functions. Okay? So wait a sec. I'm so confused because when I look at item 2 there, if you asked me what P was, I'd go, oh, P's a variable, right? We'd have done that for a really long time. But if you covered up everything on the screen except this and said, what is P? You'd have said P's a function. Okay, so these functions that have public overloaded parentheses operators are called function operators. So objects with overloaded parentheses are called function objects. And there's another name for them, or functors. And you can explain to me why that makes me giggle every time I say it. They're functors. They're fun. All right, any question about it? Okay, so this is a thing with overloaded parentheses, which means it can appear both as something you declare and as something you use like a function. Okay? All right, so now let's look a little bit more at this. So I've got a little bit more code for you. And what you'll notice immediately is we're kind of done with animals here. Okay, we're kind of done. There's no reference to that original example for a moment. We're just looking at this like code that is very generic. It's very abstract. There's nothing specific about it. What I want to know is first of all, what's the function called? What's the name of the function? The name of the function is simply print, right? There it is. You know how to find that. Whose inputs are, that is, whose parameters are, what are they? What type of thing are they? They're two. We don't know what they are for sure. It's a parameterized type, but the way we're going to use them, and the hint on the screen by their name, is that they are two iterators. And yeah, it's a formatter, but how is that formatter used? I don't even know what a formatter means. So, and a formatter, and I'm going to put a ton of question marks around there. What do we know about the formatter? Its object is going to be both a parameter and a function, right? So this specifies a functor. Okay. Now, what does print do? What do you think print does? Well, the first thing is not the same as, well, it's not the case that the first has made it to the second. Okay? We're going to apply the function to the first thing's data and then move the first thing forward, increment the first thing. Okay? Yeah? All right. So the function appears to apply printer to everything between first and second. Okay? Is that all right? So remember, all right, so yeah, so it doesn't matter what function we pass in. It doesn't matter what function we pass in. This function, it doesn't matter what our printer is, print is going to apply it to the data that we get out of the iterator. This is a way of mapping a function to every element of a container. Okay? It's a way of mapping a function to every element of a container. Is there any question about it? Is it all right? All right, one more. You ready? Okay, let's pull them all together now. Let's pull them all together into this. All right, so what's going on? We're going to take our printf-big class that we overloaded from before. In MP4, I believe this is a color picker. I think that's right. And we're going to declare an object of that type. Okay, so we've got this generic thing called a printf-big. It's got the overloaded parentheses, this functional type that has the parentheses operator overloaded, and we're going to declare one. That is, we're going to build ourselves a functor called myFun. Now we know that print wants one of those things. So myFun is going to be the thing that gets applied to every element of the container. Now, where's the container? Okay, well, look, we've got a list of animals, remember? We're defining an iterator. This is the type of thing that we're going to demand for both of these things. Okay? So my challenge to you is to tell me, if I implement all this code, what do I get out based on the data that we put into it last time? What do I get out of it? I get all the big animals, right? Because I'm going to print out the name and the food only if they're big. So this prints all the big animals. Now, I have a true confession here, and that is that every time I design one of these things, I spend a lot of time debugging and trying to figure out just where all these pieces go. By way of example, last hour, and I don't say this to mock at all, I say this because I identify with it. Last hour, the person goes, one of the people said, why are you comparing the left-hand side and the right-hand side? So this act, this art of matching up the angle brackets as part of the templates, it's fraught with error. And that's just the syntax, the design, and recognizing that you can create functions to apply to every element of a collection or a container, that's the part that's kind of new. Other languages, like functional languages and even Python, make this much, much, much easier than it is for C++. But it is what it is. This is how we're doing it here. Okay, any questions about that? You doing okay? So I think you should be kind of going, ugh. It will become much more palatable for MP4. So raise your hand if you've already started working on MP 4.1, and leave your hand up if you're already done with 4.1. Okay, so the tax of being in the front row is I'm going to ask you a question. How many lines of code did you write for 4.1 approximately?
Maybe like 20.
Yeah. Okay, so if you're working on 4.1 and you wrote 20 lines of code and you're going, whoa, this can't be right, it's right. Okay, so it's supposed to be pretty straightforward. 4.2 is a whole bunch of messing around with this kind of syntax, attaching these abstract functions to what you're trying to do in the MP. I guess we're done. I don't know about you, but I'm ready to be done 2 minutes early.